Hello, everyone. We are starting. I'm so excited to be here today for many reasons. I'm sharing the stage with very great guys. And that's my second time in the United States and first time when I've given a talk in English and in the United States as well. So today, we are going to run the workshop calling from top to house. And Wade, could you please introduce yourself?
I'm Wade. I work here at Moov, and thanks for coming to the conference. But what I'm super excited about is there's a couple people at Moov, and Adam and Pavel are two of them, that allow me to stay kind of technical, and they're way better than Claude and ChatGPT for answering my questions. And so thankfully, I actually got to write a bunch of code with these guys in order to do this project together.
Hey everyone, my name is Kornafeld. I'm a software engineer at Moov, working in card payments. I recently contributed to Tap to Phone. It's an awesome kind of like new technology. If you are interested and would like to learn more, please come and chat with me after, or do listen to my colleague Richard's talk tomorrow at 1 p.m. And what other thing can I say? So I won't even try to compete with these two in terms of credentials. So let me just say that I have roughly 10 times less experience in payments than Pavel here. So I do cherish the moments whenever I get to show him a trick or two, but most of the time it's him showing me the tricks.
So my name is Pavel. I have almost 20 years in fintech. I started in 2006, and I realized with my attention to the details, with my approach like to polish things, fintech is ideal field and area where I would want to work, because it should be solid, reliable. We deal with money, so you don't want to screw up this. And I'm from Poland, and originally I'm from Belarus. And so thanks, Mac, for so in our family we speak Russian, and outside I speak Polish, and when I work I speak English. So in many times I just feel dumb because I can't explain the idea I want to explain. I think it's not bad today, but before it was very painful. So the goal of this workshop is that every time you tap your card and you hear the chime, we want you to remember what you saw and did here. Things that we will run and show today are built on top of open source. And Moov has a lot of very solid production tested open source packages. And in this workshop, we'll rely on ISO 8583, ISO 8583 connection, and on BERT-TLV. But you should know that all other packages are very solid and reliable. I hope that you had enough time to prepare for the workshop. And this is our plan. So there will be a high-level overview of the actors and payment flow. Then Adam will set up an issuer, will issue cards for you. Then I'll set up acquire, and you'll set up acquire. And then Wade will show the terminal part. He'll show how to read the card and actually process the payment. And then we'll go deep into the ISO 8583. And in the end, we'll have one more thing. So please be aware that we have a lot of moving parts in this workshop. And we have devices. not all of them reliable. We bought them on AliExpress. So we lack of different validations, verifications, so it can crash. Security, forgot about it. Yeah, so you will show pans in logs, but don't do this in production. So it's fragile. You may have to restart something or try multiple times. So the actors in the card payment, like these are the actors. There are more than these, but we don't want to go and discuss like different grades of them. So on the right side, there is a person, card holder. So someone who opens an account with the bank or financial institution, and then this bank issues a card to this person. Then on the left side, the same person using the card go and buy something or pay for coffee, and this payment is accepted by merchant. The merchant usually uses a terminal. And then this data, the payment information, is sent to acquire, and acquire sends that to the payment network sends this to the issuer, and then it goes back. So these are the actors. We will run and operate today 3 big components. First, issuer. Second, acquire, and then terminal. And now, Adam, over to you.
Thanks, Pavel. So as Pavel explained, first we will look at the issuer side and see what happens there. So at the very basic, the issuer is a bank, and it just does 2 very basic things. It creates and manages bank accounts, and it issues payment cards. If we zoom in, like put on our software engineering goggles and zoom in a bit, then this is what we would roughly see is that the issuer bank manages an API. They usually connect to a core personalizer when it comes to issuing the physical cards. These are often like separate entities, and I just actually learned from one of you yesterday that there is a company, it's called CPI, that actually has a facility that handles all that goes into actual printing and personalizing the cards, and they just have a facility down south of Boston, in Littleton. Not Boston, sorry, I'm from Boston, but south of Denver, I mean. And so these are like super secure security facilities, and if you ever get a chance to tour one of them, please be sure to take advantage of them because they are super cool. Right, and then so for actually writing the card, we have these NFC reader writers that you also have. And one thing that I wanted to point out is that this NFC technology is not, as you might already know, not specific to card payments, so there is a myriad of different applications to it. And one thing that I kind of recently learned, I wasn't aware, that the passports are also NFC enabled, and I just so happen to be flying over the Atlantic later this week, so I happen to have my passport with me, and if I tap it, then you should hear a chime that picks it up. So, and you could actually go out and implement an application that you would be able to read the biometric data that is stored on the passport. And so the passports also come with their own standards, and the standard governs that so you wouldn't be able to tell like which page has the NFC chip embedded in it, but the standard governs that it has to be either the photo page, the front cover, or the back cover. And I tried a couple different passports, and in the US it seems to be that most of the time they are in the back cover. Just a fun fact, so you know. All right, so moving on. So we are kind of ready to create an account, create a bank account, and then issue a card. And so for that, like we need an actual card. And so for today, we brought you a technology called Java Card. So this is like everything Java, developed by Oracle and maintained by Oracle. It's a platform that runs Java applets on a secure smart cards. And it's actually the world's smallest footprint of Java runtime environment. So you might wondering, like, how does a card like look like that? Is there some kind of a like flux condenser sticking out of it or something? And I have to disappoint, these are just the most ordinary looking same as credit card. And to me, it's pretty mind-blowing that these cards are not powered by power source, so they are only powered up when you bring them close to the card reader by a magnetic field. And if you like ever like maybe saw like a Windows computer boot up and see how long it takes, you tap this, and the Java runtime environment is up and running and ready to answer you immediately. It's pretty crazy, if you ask me. So the specific card has this weird name of J3R150. You can see in the slides the parameters, just 4 kilobytes of RAM in it. So working with these cards is kind of like a time travel back in the 80s when software was limited by hardware a lot more than these days. And obviously super limited environment, so nothing fancy that you would be used to if you ever work with Java, like no multi-threading, no dynamic class loading. And even the data types are very limited. So you only have byte, int, and short, so not even string. It's like forget string, but not even the character type. So if you ever want to write your name on this card, as you will see shortly, you will have to code that as bytes, like a byte array. But still, because these are can be used for payments as well, they do support a myriad array of cryptographic algorithms, which is also kind of like makes you think that you only have these 3 types and you still have these awesome algorithms implemented. How is that possible? All right, so this is where we will look at the code a bit. So let me end. So I have the from tap to auth repository opened here that you guys are also have checked out. So we'll see, I'm just navigating that repository. And so if you go into the Java card source, first we have this hello env application, just to give you an idea of how it might look to implement like a hello world application on this card. And as you can see, as I mentioned, no character types, so you actually have to byte encode the characters that you wanna like have your card to spit out. And also there is no standard out. So the way this works is that there's a standard APDU that kind of governs how the card reader and the card communicate with each other. And so whenever the card receives one of these commands, you can write the code of how to handle that command. And as you can see here, we're just doing this like array copying and sending that bytes of the hello bytes back as the response. So that's our kind of standard out in this limited environment. But that's enough about Hello World. We came here to actually implement payment cards. So let's take a look at how that might look like. And so we have this simple EMB applet. And as you can see, it extends this applet interface. And that kind of governs like what are the methods that you need to implement to make it work. And I'll just give you a quick rundown of like there is an install command that like the Java runtime environment would call whenever we are installing the applet on the card. There's this is kind of like the workhorse method that takes the incoming APDU messages from the card reader and processing them. There's a special operation that the card can actually host multiple of these applets at the same time. So there's a method to select an active applet, which would tell like the Java runtime that, hey, this is the applet that you should forward the incoming messages from the reader, and that is the applet that should be answering those. And as you can see, what happens here is that we have this static data get FCI method that kind of, surprise, surprise, returns yet another byte array. But we can actually take a look at like what's in that FCI data structure. So if I just find it here. So similarly to how Pavel will talk about the ISO messages that happens between the issuer and the acquirer side, these are also like use this tag length value encoding, where the first byte is usually a tag. So in this case, 6F denotes that this is like a file control information template. So this kind of describes some basic information about our applet. Then it's followed by a length, so in this case, 24 bytes. And then we have a set of other tag length values. The first one is an important one. So the tag here is 84. The length is 8 bytes. And as you can see, it is followed by actually 8 bytes. And in this case, we can just read it out, and this would be like an application identifier. So it would be A0, a bunch of zeros, and then 0, 2, 0, 3, 0, 4, 0, 5. So this is going to be our unique application identifier. If you kind of, as an analogy, think about these cards as like a regular operating system, they come with a file system. And, but the file system or the files on this file system are actually all identified by this application identifiers. But yeah, so it's easier to, if you just think about them as like the file names. And then one other important piece of data here is the application label. So this would just be like a human readable label of what this applet is. As you can see, the tag is 50, the length is 0E, and we're just followed by a bunch of hex encoded bytes, and this actually encodes the label fintech defcon. So this is going to be sort of like a unique application label for this demonstration today. And yeah, so there's also like a language preference here. So 5F 2D is the tag. As you can see, the length is 2, and it's followed by 2 bytes. So 656E, I believe, encodes the characters EN for English. So this is going to be our language preference of this card application. And then finally, let me switch back to the actual EMB applet. And as you can see, so we are done with this selecting the application part, and now we just see like a giant switch operation that would take a look at the first few bytes of an incoming message to determine what kind of message is that, and just respond accordingly. And from here, we are just gonna look at quickly at this read record. If the tag is B2, and if I can find it. Yeah, here. As you can see, nothing new here. Kind of does the same thing, that it just reads a byte array from the static data structure, and it sends it out as a response. But this is where we're going to be seeing some of the personalization that gets written on the card. So if I hop back over there, so this was FCI, the file control information, and so this is record 1, which actually encodes the card number, as well as the expiry date, as well as the cardholder name. And I think by now you could have already spotted that this line is the one that encodes the primary account number, so PAN. This would be your card number. The tag is 5A, followed by the length is 8 bytes, and followed by the actual 8 bytes. The card number here would be 7, followed by a bunch of zeros, and ending in 70. The reason we picked 7 for the card to start with is that you may or may not know that the first digit of card numbers kind of encode the brand of the card. And from 1 to 9, almost all of the digits are already taken. So if you take your card out, If it would be a Visa, it's most likely would start with a 4. If it's a MasterCard, it's most likely it would be start with a 5. It's not like a rule. There's more nuance to it, but it's a general idea. And so we just picked 7 for this demonstration because 7 and 9 are really the 2 digits that are like not assigned yet to any brand. And the other kind of interesting tidbit about these card numbers is that the last digit is actually a check digit. There is an algorithm called the Luna algorithm that is used to calculate like the final digit based on the previous ones. And it just happens that if you'd if you'd feed this card number into a Luna algorithm, it would say that this is a valid number. So that's why it ends in 70. But if it was to switch it, if it would end in 07, it would fail the Luna check. That's just an interesting tidbit. Application expiry date, so this would be like the year and month of your card's expiry. As you can see, the tag is 5F24. The length again is 2. So these 2 bytes encode April, as you can see, 04, and 30 is the year, that's 2030. And finally, we have this long one here, which is 5F20, is the tag. The length is 11, and it's just a bunch of hex characters that you see here. This would be the cardholder name. In this example, we just used Wade's name. So yeah, and the idea here is that we have a bunch of these cards. We have roughly about 2 dozen, and we'll be handing out to you after you personalized it. But to do that, and so this is where you guys will start acting as your own issuer banks. So if you set up like Postman, and if everything worked out, then you would be able to open this issuer folder, and you would see this create account option. And if it's set up correctly, then this base URL tag here would not be red for you, but it would be blue. If it's red for any reason, just don't worry. You can just plug in HTTP localhost like 127.0.0.1, and the port that your issuer is going to be running on is, just a second. Say again?
Told them to run the issuer.
Yeah. Oh yeah, so yeah, it's actually easier if you just run the issuer. So if you open up a terminal, navigate into that folder that you have checked out the repository at, and you just run make issuer. That would run the issuer server for you, and you would see here that it's running on port 9090. So if you just copy this over to have your base URL, then it should all be working. I'm going to be running a presenter mode, so it's going to be a tad bit different for me, but otherwise it's the same. And just one more thing is if you don't have Postman or didn't want it to set up or whatever, you still have the option to use command line. If you look into the source code and go into docs, you would see this curl request, and similarly you can just copy this part here. As you can see, it's localhost 9090/accounts, and it's making a post request to actually open a bank account.
Could you please raise a hand if you have issuer running?
Oh, cool. Wow, you guys are great.
Okay, thanks.
That's why we give prizes away, then they follow along.
Yeah. So I hope you personalized it. So you didn't send in the default owner name, but you personalized it to yourself. The reason this is important because so you first open the bank account, so the bank now knows what your name is. And when you say that, hey, could you guys give me like a card that would go with this bank account, they will not be asking for your name again. As you will see in the next request that we are making, they will just use your bank account's owner name. And for today's demonstration, I will be putting on my Mickey Mouse costume. and we'll be impersonating Mickey Mouse, and I'm going to creating this account. And as you can see, it returns with a 301 created response. Pretty much all the input is just echoed back other than the ID. So now my account has been issued a unique ID. If you are using Postman, the next request would be like getting the account details. So this would just return to you the same information. Maybe with the only difference is that now you're seeing that your balance is your initial amount that you provided, and then there is this extra line here that is the hold balance, which is 0 right now because we haven't submitted any payments, so there hasn't been any holds put into your account. If you don't have Postman, and if you're using the command line, you would need to copy this ID that the create account returned to you, and you will be you have to like paste that into the account ID part of the URL here, but otherwise it should work for you. And now all we have left to do is actually issue the cards. And similarly, how it would work out in the real life, you guys each have your own issuer banks, so you are the banks, and I'm going to be like the separate entity that handles the nitty-gritties of issuing or personalizing and delivering the physical cards to you. And so that we are going to be using this other endpoint, the issue card. Similarly, if you are using Postman, the account ID is already here for you. If you are using command line, please don't forget to copy this. You can provide a bunch of details. Again, in the real life, you would not be providing this, or the bank is not providing this, but for demonstration purposes, we figured maybe you can customize it with like an expiry date, so feel free to update it. Just make sure that it follows the MMYY format. Same for the PIN and CVV, but for this workshop today, we are not going to be using these two values. Yep, and then it takes a query parameter, which is flashcard equals true. So if you set it to true, then your issuer instances will reach out to my computer, and my computer is running this special card personalizer service, which is hooked up to this card writer. And we are going to be, I'm going to be issuing the cards for you. And it comes with a piece of UI. Just have to exit this one. And I also have to start the card personalizer. So as you can see here, I have this card personalized instance. It wasn't running before, but now it is. And so I can go back to Postman and issue this request. And what you would see is that this is just hanging for response, waiting for the server to respond, and it's not responding. The reason why is that now we have this queue, and wow, you guys have already submitted a couple of cards. As you can see, I'm only number 3 in the queue, and they are hoping to, or we are hoping that they will come in. And so while you are working on that, I will start issuing the cards. It takes about 5 seconds for the writing to complete, and it will go in order. Oh, and before I do that, let me just mention that this actually made us to implement like a queue, and we are actually putting humans in the queue. You have no idea how hard that is. Like, if you're looking for a challenge to implement, try implementing a queue. There's like a myriad of like edge cases, and it's just crazy. So what's going to happen is that I have the card reader. It will detect when I put in the card. It will start writing. Satnam will be the first. And once it's finished, it will show us a bit of an animation to tell us that it's done. And it will not start to write the next card immediately, because that would just overwrite it. It will wait for me to remove the card, and then it will remove the first entry from the queue. So let's see if this works. Fingers crossed, because this is the most kind of complex part. It's working. And as you can see from the animation, it completed. There is no presentation without like a AI enabling it. So I hope you guys appreciate the halo effect with which we AI enabled this workshop. And so Pavel, could you give this a Satnam?
I don't get anything
So Stefan going to be the next one. Sort of the blue effect is when the card writing is taking place. And the rainbow one is when it's done. Stefan? So this is Mickey Mouse. This is going to be me.
That's your card.
So we'll just leave this here. Next one is Shane. Oh, Sean, sorry. That's done. We have Gandalf. Ooh, I like that.
I'm getting a TLS error listed. The other API call succeeded.
This is for Gandalf.
All right, Gandalf? Oh my.
I've tried it a couple times and it always.
Next one is Juan.
So you'll just
Share.
This is for Juan Correa.
for who?
Juan. Next one is Enzo. Ooh, we have Banana. I wonder who that might be.
Who's banana?
Anna? Oh, sorry, that didn't finish yet. I think that that might have not worked. Maybe Anna, we'll put you at the end of the queue. Okay, then please submit it again.
Do you want me to send it again?
Yes, please. It will get you at the end of the queue, sorry.
You may not get a card. We have only 20.
So this is 3dev.
3dev.
Andrew?
Andrew?
It's Alexei.
Okay, so you know what? We will, we'll just rewrite that.
Satnam. Yeah, so that's validation that we forget to add to prevent like duplicates, but oh wow. So that's Irian.
You?
Oh wow, we have quite a few more to go. That's Shyam. That's fine. That will work. That will still work. James. James Howlett. Is that really you? This is Ilan.
Who'd you say?
Ilan Gitter.
Okay. Well,
This is for Anna.
the amount of card skinning that will come out of this demo is going to be insane.
Should we go to the next part?
We have Shane. Oof. We have only 3 more. But maybe you can take over the presenter and you can continue.
No, you will not know who's.
This is Yagza. This is Johnny.
Johnny.
And finally, we have Soul Patrol. Soul Patrol. And yeah, so I think with that, we kind of wasted a bunch of time, so I'm going to stop this, no more cards, and we are going to push forward with the presentation. You want to take over? And so now every one of you has your own personal cards, and they are tied to the account that is running on your issuer service. Please don't stop the issuers because they only maintain the accounts in memory. So if you start it,
No. You can.
Okay, then you can. Pavel kind of hacked it overnight. You can now. But still, just don't stop
with
it.
jet lag, you have nothing to do during the night, so just update the services, make them production ready. So if they crash. Okay. So this part will be short, and it's about acquire. So acquire is about accepting payments. Online, offline, card not present, card present through different channels. So acquire manages relationship with merchants. And in our case, acquire helps merchant to accept the terminal payments. And this is the architecture diagram. The service that we will run consists of two main parts. The API, which manages the merchants. So you can create merchant, get merchant, see the transactions, and it API to create payments. So this is API for the terminal. Terminal will submit requests to this API, and then the service, this payments API, will use ISO 8583 client, so it will send the ISO 8583 message to the issuer for payment authorization. ISO 8583 part will be later, and now we will run an acquire. So you should just run make acquire. And this is, so acquire has the address, IP address and port. And you should copy that. And if you use Postman, and you may not have this set up, so just copy it here. And now you will register a merchant. Just be creative with a merchant name. In this case, it's fintech DevCon demo merchant. So send the request, and this is the response. And just merchant has a merchant category code, which kind of tells what merchant does, like what kind of business, the postal code and the website and the name. All right, so this is the ID of the merchant. And this is what you have to copy, and then open the source code and find in the configs, you should open the terminal YAML. And in terminal YAML, just replace this with the ID of the merchant that you created. This is a config for terminal. So terminal need to know where to submit requests and some other things like the URL to print the receipt. And that's it for my part. And Wade.
All right, I only speak English, not well.
Do you have your card?
I've got it all. So,
you should zoom in a
Okay, so the piece I want to talk about is a terminal. And the terminal is, you go to a restaurant, that little thing that you tap against, or go to the gas station or whatever. And the terminal really has three major parts to it that we'll talk about. And there's actually a lot of parts, but we're going to try and really simplify some of the things here so you learn something. So first is contactless communication. So that's the actual ISO protocol for the NFC communication. That's the kind of file directory, selecting what you want to run, all the NFC back and forth. Practically, you should know that when you buy something like this, this would be a level 1 cert. Well, this thing, trust me, is not. But hardware is considered the level 1 part of the communication protocol. And so that's to make sure that there's not a skimmer in there, or there's not something that can be injected in order to consume that data. Level 2, that's the actual software that's going back and forth between the card. Does that kind of make sense? So that's the back and forth communication in order to read the chip. And then level 3 is making sure that the kernel actually performs all the functions that the card brands require. So level 3 is different for Discover than it is for Amex, that it is for Visa and MasterCard. Similar, but definitely different. And so those are kind of the 3 different steps. Specifically on mobile devices, iOS actually comes with a level 2 kernel, which is really the iOS operating system is protecting that level 2 kernel, and then it's level 1 certified so that it's not skimming cards. And then on Android, you actually have to build a level 2 kernel in order to communicate with the NFC device. And then in every case, if you want to release a kernel, you need to get certified for that level 3. And that level 3 is the communication to the payment processor. So you have payment processors like Moov, Adyen, WorldPay, TSYS, Elavon. You've probably heard of these brands. Maybe you've heard of Moov after today. But they're the low-level protocol that's actually speaking. That is the acquiring processor, and that's the back and forth that happens there. And so you can really think about that logically as kind of the NFC reader and writer. That's the hardware, so kind of that's your level 1. Level 2 is the actual terminal running inside of there, and then level 3 being the communication back out of this network. For our demo today, a terminal is taking care of things like the cash drawer, the receipt printer, telling the customer to, the amount that they need to tap to pay in order to do the transaction processing. And so that actual payment processor, then the terminal is connecting back to what Pavel is going to show. That's the acquiring processor side. All that makes sense? One thing that I want you to take away from this meeting is, next time you go use one of your cards in order to tap to pay, notice the 4 lights that kick on. Those 4 lights, the first one is actually activating the operating system running on there. This is an OS running in Java inside of there. And many applications can be put on this single chip. And then that communication that goes back and forth is where you'll see the 3 extra lights. So it's powers on, selecting, I actually have a slide for that. Selecting that contactless payment, figuring out the AID. The AID is like very specific. This is hard-coded values, so this is a Visa credit card issued by JP Morgan. Thank you for sponsoring. Thank you for the $7 card that I bricked as well. There's a lot of lost and stolen cards that come to the Arnold household. And then the data that's embedded inside of that. And so that TLV data, that's the EMV tags that are being inserted onto this card. And so the kernel, the actual low-level kernel, what that's doing is it's selecting the application. There can be many applications on there. The first application for contactless payments, we'll show code on this. There's an application for contactless payments. There's an application for contact-based payments. That's different. And on this card, JP Morgan Chase actually puts a FIDO chip inside of here. So when you start dorking with your cards, you start realizing there's all kinds of other applications that are embedded inside of here. So then we read the application, we do some card holder verification work. That data is coming from the physical card, not the issuer. Now the terminal does its own verification, so it may say, I don't really care what the issuer said, I want you to put in a PIN or a signature because I want to de-risk that transaction. And then it's sent to the acquiring processor, who sends it to the issuing processor. And for that specific kernel, you're getting data back. You can also get scripts back. So the issuer can actually send back what's called an issuer script, which is executed code that comes back from the issuer through the acquirer back to the terminal and run on the device. And it turns out you can put anything in that, which is kind of fun. That completes this entire online processing loop. You just need to do that in 300 milliseconds, and you're solid. So the actual low-level kernel, these are open standards. It's called EMV Book 4. But there's 7 defined different kernels that you can go use. So there's kind of a generic one, which is like the original Visa EMV Co kernel. And then Visa later was like, hey, we want our own stuff. So part of this process is when you read that card information, you're figuring out what the AID is, and then you're selecting the kernel, and then that's doing things that are very specific to that card network. Things like cardholder verification, transaction authorization, and then all the risk management that goes along with that. The other thing that Adam brought up is there's something called an ARQC, so application request cryptogram. And what that's doing is it's actually taking data that's on the card, it's running it through a cryptogram that gets a one-time key or hash of the data. So if you use this, every time you tap, this is why I have a lot of cards. It took me a little bit. I'm not the smartest kid on the block. Every time you tap, it has a counter that says how many times it's tapped. That counter increments. The server or the issuer knows how many times it's been incremented, or it thinks. But if you do this a hell of a lot of times in your house, you end up bricking this. So the next time you go and actually try and use that card, it's been incremented. It does this ARQ or ARCQ, creating this new hash. The hash realizes that somebody's been tampering with this card, and that's when you'll get a response back that tells the merchant to pick up your card or your wife's card if they have the same PAN. Whoops. So that's a whole bunch of stuff. What we're going to do in our terminal is something very simple. We're going to build our own card brand. So we're going to select that file control indicator, which is something that Adam was showing earlier. And then we're going to extract that card holder data. So when you customize your card, that went into that card holder data. But for fun, what does a real kernel look like? So a real kernel looks something like this. You have, you're booting up, so this is a full implementation, all 7 books of the EMV kernel. It's booting up, and it's doing things like, what type of merchant is this? Retail store, here's the merchant ID, terminal ID. We can have more than one terminal at a merchant, country code, floor limit, CVM limit, which means at what point do I ask for a PIN? So all that data is going through there, and we're just going to send this to a mock payment processor on the back end of it. So we've got a card reader, put in $100. Good guy, it's 20% tip, plus it's tax-free now. All right, so I just wanted to walk through this before we do our demo. We aren't sharing the full Go kernel with everybody, but just to kind of walk you through what just happened, we've kicked this on, the merchant information is there, we've kicked off a new transaction for $120, we detected a card through this device here. We've realized this is a contactless pre-processing payment, right? So we're going to, this number is hard-coded in every one of these chips. So this is a known folder on every single one of these cards. So if the terminal accepts contactless payments, it means this is literally the folder name. All right? And then when we select that, what we're doing inside of here is we're asking for AIDs. So in this case, we're getting a couple different. Visa credit is one of the AIDs. You can put multiple things on here. So a lot of times if you're a backup card, will have other AIDs on it. So maybe it's Shazam or Pulse or NICE can have a debit transaction inside of there. We've selected the Visa credit AID. This has said, oh, that's kernel 3. That's what we need to do. And now we kick through all those bullet points that I just talked about. So we're initiating application processing, which is sending a command. It's reading the data. It's generating the cryptogram. It's sending that off to the issuer via the acquirer to the issuer and kicking back. And in this case, we didn't reach the card verification management settings. All this data is really kicking back from this card. So this is kind of nerdy, but fun. Type 2 fun. But for what we're going to do, I'm going to first do something so you guys can play with this at home, and you will eventually brick your devices. But inside of the project that we downloaded, we're going to read these cards, but first we have the ability to kick off a universal kernel. It's not a full implementation of the kernel, but what it does do is it allows you to print out everything. So again, if you send those parameters, you want to play with that. Oh, I need to put money in there. So we'll do $1. So this allows you to have that same code to allow you to go kind of figure out what all the data is inside of that EMV chip that's running there.
This will not work with your white cards.
So yep.
Just use your real cards and we collect your card number.
We didn't bring Jeff here. He's our CISO. He really enjoyed this project, by the way, because every time we use Slack, what are you guys sending?
You can run make terminal. That's the same,
Yep.
make terminal.
And so the second thing we're going to do here is we're going to run, this is the fintech DevCon kernel. So we've made our own kernel to just simplify this, just so you can learn what's going on. So obviously we're going to get exactly what Adam had shown was written onto the card, right? So all of your cards, if you run the terminal, when we run this, oh, I need to put amounts in here. So let's do $10.
One sec. You should, sorry.
Which one did I get?
Switch to the,
Should I just do make terminal?
no. Config. We should switch to the config. Configs. Some configs.
Yeah, I had it open.
So this should work on your computers.
Yeah.
Did it work? Yeah, just try, unplug, plug. We tested it on our computers. It worked. Oops. Yeah,
Oh, you need to start an acquire.
Acquire is up and running.
Okay, on their machines.
Yes.
Yep.
And here you have to.
Oh, I'm going to.
What?
I got it.
Yeah, one sec.
All right. We'll go back here.
Yeah, just try again. So, and you should hear this. Please repeat.
Well, I think we need the prayer URL.
Do you hear it?
Like, this is what the terminal
So,
config looks like.
guys,
when
you
download
can
it.
came
And this
here
is the printer you are
and
the
get
right one.
receipts.
Oh,
You
it's
can
saying
find.
it's offline.
So I'll do this.
Try again.
This is your named receipt, you know, is your name. Yeah. So wait, you can get.
So the kind of fun thing here is Enzo.
It's a demo. It's a workshop.
Satnam.
Gandalf?
More Enzos.
Gandalf? Okay, Richard. Enzo, okay, this is yours.
Can you pass
Juan? Juan?
Pass it on.
Banana.
Yeah, just play with it. So we need more receipts.
Oh, I forgot. Mine's not even working.
Oops. Shyam. Sorry, you should retry.
Yeah. It should decline.
Anyone need help? Yeah, just do this. Put it here.
All right, Adam, you want to
Unplug.
move on to the next one? We need to keep it going. You got half an hour left.
Card on the reader. Don't tap it, just put it. It will be more reliable. So.
Yeah, Ingenico and other people are a little bit more sophisticated on the
Stefan?
retry strategies than the
Stefan here.
Alibaba NFC reader for $7.
Ilyan? Can you pass it on? And I have Yangel.
Yep. Yeah. 7 versus 70 is a retry logic. The other thing you'll notice is most modern contactless payment terminals now will have
put it here.
a big antenna. So you'll actually see clear plastic at the top
Enter the amount.
where you tap to pay. And that's it really helps with
don't add dot.
metal
It
cards
should be
and
inside.
also with this.
If you want
So
$2,
everything
it
we're
should be
doing
$2.
here, if you want to load up a card off of your wallet, all of these cards will work for debugging and all that type of fun stuff too. Just don't run them too many times until you do a real transaction. You can kind of get away with about 15 taps before the issuer tells you to pick it up.
Oh, you know what? Printer is my laptop sleeping, so it just disconnects printer. Sorry. It's ready to accept payment. Here we are.
So your card actually didn't print the receipt. It didn't work.
I love
Can you
it.
try
I was
it
just
another one?
grabbing a bunch of stuff from here.
Okay.
Yeah. So the fun thing is you're decrementing your balances right now as well. So however much money you put on your card is not there.
Ian Gitter. Sorry. This is yours. Joan is. This is yours. And James.
I was looking at the transaction.
No.
I purchased $1.
Okay, we have more receipts.
Okay, so with this, we have kind of come full circle. And when you run your, or tap your cards to the terminal, it's connected to the acquirer service that's running on your computer. That's all localhost. And then it made that ISO connection to the issuer instance that's also running on your computer. The issuer verified that this card number belongs to an account there, and it checked whether that account has correct balance on it. And so now you can go back to either Postman or via the command line, and you should try using the list transactions endpoint. You can just send it. It didn't work for us because this is a workshop, but you should see like a transaction appear here, not just an empty list. And you can also try the get account, where you should see that your balance has been decreased, and you should see a hold balance amount that should equal to the sum of the transactions that you tapped your card with for.
Wake up, Peter, wake up. Huh? How, yeah.
Oh yeah, I can do that. Caffeinate.
Oh, just. Oh,
Just that,
caffeinate.
yep.
Okay.
But you have to enter the command after that.
Wait a second.
Or that works as well. If you have it in a different window running, yeah, that should go.
I should.
Show of hands if you saw your balance decrease. 1. Awesome. So it worked. So Pavel,
Yeah.
can I take over?
Yeah.
I don't know where we are.
Okay.
Yep.
Now it's to me, right? Okay, so we have one more banana, finally. You just give a second. Just
Can give it to her.
carefully, like this. So on your receipts, you see the cardholder name, the authorization code, the response code. Feel free to send to play with it. So these are the components that are up and running on your computer, right? So you see it works. Even this beautiful printer prints the receipts. So let's zoom in a little bit to this payment flow. So we have merchant terminal which sends payment request in JSON to Acquire API. Acquire in real life creates ISO 8583 message and sends this message to card network. Then card network, it has like a network of issuers, so it routes the message to the issuer which issued your card. So in our case, it's simplified. You have one issuer. So issuer authorizes the payment, and then response go back to the card network, to Acquire, and to the terminal. And so now, about ISO 8583. So this is a standard for formatting and transmitting the financial messages, which is used by in card processing between terminals, acquirers, and issuers. And usually, as engineer, we get like a lot of PDF with a lot of pages, like 300 pages. Usually, it's so unclear, so thanks to AI, Claude, and ChatGPT, you can understand it. So ISO 8583 defines the message format. The fun thing is that it's a standard, right? And the idea that everyone just uses it to build the messages. Actually, each payment network, Visa, MasterCard, Discover, use different encodings, different fields. Main fields match the specification, but they have a private data and other fields. So where they put our own implementation of this standard. So ISO 8583 defines the message format. So message consists of, let's say, 3 parts. Message type indicator, it's like a transaction type. It's like authorization. It will be 0, 100. It can be network message, like heartbeats, or it can be adjustment or financial message. Then there is a bitmap. So bitmap has bits set. So if bit 1 is set, it means that field 1 is in the message. So the message is schema-less. So in a JSON, you see the name of the field, right? So you can parse it. So you don't need the schema. But with ISO 8583, if you get the message, you can't parse it. Unless you, I don't know, like, know how to read it, or like, oh, I know what it is. So you need a schema. And bitmap indicates which fields are present in the message. And there are message fields. Fun thing that field may have own subfields, and like so on and so on. Then there are like network connections. So I was curious, like how acquirers connected to the network, because before joining Moov, I built like a lot of payment gateways on top of like, I don't know, like CyberSource, MPGS, or some other payment gateway. And all I saw is XML or JSON or some other fancy like HTTP post request with some fields. Now, at Moov, we have like direct connection with all major brands. And this connection is a socket connection. So it's just a socket connection. You write to socket, and you read from the socket. And there are some things that I want to highlight here, like message interleaving, message matching, and binary framing. So on the left, there's like acquire sending messages. And in the middle, it's a network. So I'm thinking about it like a pipe where I'm putting one message, then second message, then next message, and next message. The fun thing is that responses to these messages will not be in the same order. Why? Because network routes that to the different issuers, and the issuer can be on the other side of the planet. So it may take just physically more time to deliver that message to the issuer. So messages are kind of shuffled, responses are just shuffled. So the idea is that first, you just write messages and you just read messages. It's very similar to, I guess, HTTP 2. In HTTP 1, you connect, send message, get response. That doesn't scale. For Visa, MasterCard, that doesn't scale. That's why there is a permanent connection, and you just write these messages and read responses back. One interesting fact is that all these ISO 8583, this socket, this message writing, message reading, is there for more than 30 years. So these envelopes, these messages, are sent by acquire.
Acquire to terminal?
No, to the network. So terminal is hidden here. Okay, on your side it's hidden here. So this is here the terminal. Terminal sends like bunch of terminals, and every terminal sends their own message, and then acquire kind of makes this sending process linear. So it's not asynchronous or parallel, it's just one socket.
Yeah, that's what I was thinking. Okay.
Yeah. For sure, for redundancy, you don't have, you just don't use one connection, right? You have 4 or 10 connections with the network.
I guess I'd add in. So original terminals spoke ISO 8583. So, but they would do a generic schema, which we're going to build a schema that would be like the TSYS schema for ISO 8583, regardless of card network brand. And so that sends that message, and then the acquiring processor, which actually has circuits, This IP address is this data center at Visa. So we decompose the PAN, we look at the network, and then we're literally sending it over a socket connection to Visa, or MasterCard, or JDBC, or Discover. And so if you think about like the innovation of a gateway, what's an online gateway? So Authorize.net, Stripe, Braintree, are some of the most popular ones. They don't actually process payments. I think they do now. Stripe does some stuff now. But, or like Square. Square doesn't process payments. Stripe, Braintree doesn't process payments. They take a gateway, which is HTTP posts, translate it, like Authorize.net, then took your HTTP post, mapped it to the ISO 8583 specification, and faked a point of sale for online transactions. And that's where card not present came from. So that's like a virtual terminal is how that all started. And now obviously a gateway does subscription billing and yada, 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 yada. But it was really an internet gateway to mimic a point of sale against an acquiring processor.
Yeah, so this is about message interleaving and message matching. So you need a way to match these messages, like response to the request. And every message has this field number 11, STAN system trace audit number, which actually is used as an ID to match request to response to the request. And one more thing is called binary framing. When network, like recipients gets like a bunch of messages, it should know how much data it should read, like to get one message. So there is a thing called lens header. So it can be different for different card networks, but imagine that like first 2 bytes just tell what is the message length. So recipient reads this 2 bytes, it knows how many data it should read for the message. So it reads the message, then read the length, okay, read the message. And now it's exercise time.
Yeah. So that's really important, right? This is 50-plus-year-old tech. So I'm 48. I don't know when you did computer science classes, but remember we had to allocate a buffer in order to read the byte stream into the existing buffer allocation. So that was like the crap we used to do in C. This is all written in C. So you have to have that length in the first 2 bytes because you allocate a 4-byte buffer, read that, increase your window length, allocate the memory, now you can parse it. Sometimes people are like, well, why is that not JSON? It shouldn't be. It really should be protocol buffers in today's. And an ISO 8583 message looks very similar to a protocol buffer. It's packed, just missing the types. You have to use a schema in order to get the types out of it. But that's like what we do at Moov. We give you a Kafka topic and you write protocol buffers and then we transfer that back into the ISO 8583 message. But the beauty of the schema is the network effect. So there's, 8.5 billion of these. Was it 144 million endpoints in America that this works at? And so even though we probably can all agree that HTTP could have been better, or ISO 8583 could have been better, ubiquity, network effects, is really the power of having this protocol.
Yeah, let's write some code. So first, just read the last point, please.
Tell me to shut up in Russian.
So you don't feel bad that you didn't participate in the one more thing. So what we'll do now, we'll try to do that in 15 minutes. We'll create an ISO client. So if you remember this schema, there is Acquire. It has ISO client. And the goal of Acquire to get this JSON, data from the JSON, build a message, keep the connection or connect to the issuer, send this message to the issuer. Yeah, and now you should open the exercises main.go. And let's just do this. Let's just go run exercises acquire main.go. Okay. It should not fail. It should print something like that. Did it work? Okay. Let's get back to the code. So step number first. We should define the specification. So we have this toy specification which is used by our issuer and acquirer. So it close to what you get from card network. So it has different confusing things. So this is like a table with a list of fields that are needed for message with MTI 0100 and what will be in the response. So you see like a bunch of fields like primary account number, amount, transmission date time, approval code, authorization code. This is what you will get in the response. Currency and acceptor information. This is a composite field. This field has own subfields. Important part here is the format. It's alphanumeric. Most of them is alphanumeric, and the length. Below, you can find the description of the data elements or fields. And we will go back to the code. This specification that you see on the screen is actually, it represents this specification from this document. And so our task right now to add two missing fields. So this specification missing two fields, field number 2 and field number 3. So you can follow what I'm doing, and what I will do, I'll just copy and paste and just create field number 2 here, switch to the specification. So it's variable length up to 90 characters. It has length prefix. So same idea. When recipient reads your message, it has this spec. So when it wants to read the pen, it's like, okay, how many digits should I read? And this length prefix actually tells the recipient that there will be like 16 digits or 19 digits or characters. So in our specification, we sent length to 19. It's primary account number, thank you, Copilot. Prefix, okay, is not fixed, it's LL. It means that in the message there will be 2 digits. That's it. Actually, description can be anything. So let's add field number 3. And field number 3 is amount. And it's numeric, 6 digits, left parted with zeros. Okay, let's just copy this, field number 2. But it will be not string, it will be, okay, can you please, numeric, okay. What's wrong? Okay, it's because field number 3. Numeric length should be 6. It will be amount, please. Okay, thank you. And the length is fixed. Okay. Oh, one more thing. It should be padding left 0. And you should padding. Now what's wrong? Define padding. How's compound? Ah, thank you. Padding left. Okay, so we are done with this task. I think that you're faster than I. Okay, one more task. This is you can see this is field number 10. It's acceptor information. And in the spec, it says it's a composite field. And it has subfields. And each subfield has a tag. And it's missing tag or field, subfield with tag 01, merchant name. So I think that I can do this. Okay, I'll just copy this, paste. It's tag 01. The length is, I don't remember, 99, and prefix is 2Ls. Okay, it's 99. Merchant name and LL. We are done with this one. Next. So we have specification defined. Now we need types or structs to populate our data with, so we can send this data to the issuer. And it also missing same fields. So if you have Copilot, it will figure it out. But field number 3 should be int 64 because it's numeric. And also you can notice that similarly to how Go works with JSON or YAML, it uses the field tags. So this is how this field is mapped to the field 0 in the specification. And here we are adding the merchant name. Okay, we are done. Let's check our main function. We create the message object. Now we have to create data. So you can put whatever number you want here. You can like 4242, 4242, and 4242, okay. Or you can just copy your pen that was issued to you. Amount is $10. Okay, we are done with these fields. One more field, merchant name. Okay, so we have data and we have message object. This message is empty. So let's set data, let's populate message with this data. For this, there is a method Marshall. It gets this data. After that, our message is populated with the data. And now we should pack the message. Packing means just converting all data that we set into the binary form using encodings, paddings, and all other things from the spec. And what we have to do, let's see what do we have okay, this is actually, doesn't matter, what we have in this packed. So I just print the packed message. And let me just run it. Okay, so you see, this is a packed message. And what we're going to do now, we have 5 minutes left, which is not really good. So I just know the spec. So the first is this set of characters is MTI. Then this is a bitmap. And sorry, this is a bitmap. I have a cool way of showing this to you. I hope that this is visible. So if I paste this bitmap to calculator, it shows the bit set. So bit number 1, it's a bitmap actually. So field number 2 is set, field number 3 is there, field number 4, field number 5, no, field number 6, no, 7, yes, 8, and so on. So now you know how to read the bitmap. Next, I know that 16 is a length prefix, is 2 digits. So this is primary count number, is like 2 digits, telling that, you know what, next 16 characters is pen. So I know that it's like 4242. Okay. What after that? Amount. Okay. This is amount. It's fixed, 6 digits, 0 padded on the left. So we will not go. So you can see that this is tag 01, length 14, name of the merchant. Tag 02, I don't know what it is, most probably 1, 2, 3, 4. Tag 03, and so on. So this is how ISO message is built. So we parsed it manually with you. Okay. Now we will establish connection with the issuer. So you should have issuer up and running. So this is, as you can see, just like simple connection, creating the connection to that address, nothing fancy. So this is, remember, this is a message length header. So we should tell issuer about the length of the message, and it's 2 bytes. You can just ignore how we calculate these bytes and how we build this data. So we have this, so this is the length of the packed message, and we write this length to the socket, to the connection. Then we write our packed data, and it should say like message sent to issuer successfully. So let me just, okay, message sent to issuer successfully. And I have issuer up and running. So it in the logs, if you switch to issuer logs, it says like authorizing request, our amount, currency, merchant, fintech, defcon, pen, expiration, and that's it. So we were able to send the message to the issuer. Congratulations. Let's read response back. Again, issuer knows that it should respond with this message length header. So we read 2 bytes, and we have a message length. We create memory, so we can read data there, and on this line, we read message. Now, we can, okay, what we can do, we can create message again. We will unpack the message. So we have packed data. We'll unpack the message. What this does, it takes these packed values and populates message fields with the values from the network that were received from the network. Sorry, I'll ignore this, but you shouldn't do this. Let's print FMT print F, please. Okay. Oops. No, I want it packed. So this is the response from the issuer. It's MTI is 0110. Then, as you may recognize, it's a bitmap. And there are some fixed data, like authorization code and response code. And one more thing. Let's do this, because we are run out of time. So we will, ISO 8583, describe, and MSG and OS std out. Oops. Okay, so if I run it again, not this, you can see the let's say human readable response. You see the bitmaps, the bitmap with bits. You see that there is a message MTI that there is approval code 14, which is unknown card because, yes, 4242 wasn't issued, and system trace audit number, that ID that allows us to match request with the response. So we are done with the exercise part. Thank you. Now we should, I think, skip what we have accomplished and go directly to one more thing. It's a pizza challenge. So Adam came here. So please just explain the challenge.
So yeah, we have pizzas here, 3 of them. And if you guys do this, you win a pizza.
Yeah, so the challenge is, so I will run one more thing. Okay, it's up and running. Okay. So you will have to add one field to the specification, your name, to this exercise file. This, then you'll have to send a message to this pizza server. It will print the receipt. Then first person in this list of the receipts, the last person, and the random person in the middle will get pizza. Now, I will show you what you have to do. It's docs. One more thing. It's hidden. It was there. You could prepare already, but okay. So you should add field 25 with participant name. The type is string. Its variable length up to 28 characters with length prefix LL. Okay, I'm waiting. I'm waiting.
Did you start the server?
Yes.
So the pizza server is up and running.
Pizza server is up and running.
And
yeah.
the game is now on. Good luck.
The first one, lucky.
At least one.
Please, please. I'll start giving the hints in 1 minute.
So each quarter, card networks do updates to their schema with additional information. And so that's part of the release candidate when they say, oh, this extra field is now required or now optional. These schemas need to be updated.
Sorry, one more thing. I forgot about one more thing. And it is, you have to send request to this URL. Just, sorry, I will put it here. You don't have to do the TCP. Just change that. Okay. Because maybe you were like, oh, I'm not getting a pizza. Sorry. So you were sending request to your local issuer, but you have to send it to pizza server. All right, I'm giving the hints. First, spec, just copy, I don't like pen, change the ID, field ID to 25, change the length to 28. First thing. Second, there is authorization request type. You need to add field there with field tag that will map this field to the field in the specification. So you should find this authorization request type, and you should add field there, tell the ISO 8583 tag 25. And finally, when you create the data, don't forget to add participant name there because, okay, I don't see any requests. yet. So any?
Yep.
Okay, we got like a connections. Yeah, I'm seeing the connections are like connection closed. Okay, so it says that someone is trying to connect, maybe not sending the data. Just let me check that. I'll just restart the printer. It's up and running. Okay, 7 TCP and grok. And you know what? Let me just send request to it myself. I hope that it's not an issue on my side. Message sent. I think that all right, so if you don't want pizza, you can leave. I'll just do this myself. So.
Can you show the URL again, which we need to make?
Yes, it is this one. So it's something wrong with this pizza server. You know what?
Should I just generate random numbers? And
No, just give me one sec. Starting on 85, 88. Sorry. What's going on? I know, I just don't want to fix that. Okay, I have. failed with pizza server. So, yeah, it may take some time. So maybe we'll create something like after lunch, I'll have my laptop. Where?
At the Moov booth.
At the Moov booth.
Yeah. That sounds good.
Yeah, so I'll just fix that.
We're already buying beer for everyone here, so might as well get
Sorry.
some pizzas too.
It worked on my machine yesterday. I know what's going on. So. But again, so just summarizing, so we made it work from end to end with card issuing, with creating a merchant with acquire, with reading card, with NFC, processing that end to end. And what's most important, printing the receipts. Yeah, so thank you.
Thank you for coming. We hope you guys learned something.